Hi, my name is John. I'm a chemistry teacher at a local 5A high school. What I'm going to do today is I'm going to show you how to use the Vernier Labquest. This is a handheld device. The students really like using this in a laboratory setting because it is digital. It's touch screen. There's a lot of different things you can do with this at the same time. What I'm going to do is, I'm going to go ahead and turn it on. As you can see, this is just a blank home screen. There's a set of buttons at the bottom. If you don't want to use the green stylus, you can just click with your finger, or you can use this stylus and click on the screen a lot of the time. If you look on one side, there's a couple of digital ports. Those are for different probes. On top are there's 4 more channels for some additional probes. Over here on the side, there's a place for a USB outlet. There's the power side microphone, and you can hook up headphones to it as well. It's kind of tough to see, but this little hole up here is a built-in microphone in case you would like to take notes and just speak them. What I'm going to show you is something quick and easy. It's for an endothermic and exothermic lab. The good thing about this is all you have to have is a temperature probe, and we can measure the change in temperature of solids, liquids, gases, things like that. So what I'm going to do is I'm going to go ahead and I'm going to plug my temperature probe into channel 1 on top. It fits in there nice and easy. On the side, these digital channels, sometimes students try and force the probe in there, so make sure to tell them that we're going to plug it into channel 1 that's on top. What you're seeing now is a real-time display of the temperature. It's currently at about 27.45 degrees Celsius. If you would like to change that temperature and change the unit, all you have to do is click on the screen and you can change that to degrees Fahrenheit. So it's around 82 degrees in the room that I'm in currently. I'm going to go ahead and change that back to degrees Celsius. If you notice, here's the end of the probe that I'm using. If I grab it with my fingers, the temperature starts to go up because it's real time. This is taking the temperature right now, and as I let go and you give it a moment, it will start to lose the heat that it's gained, and the temperature will start going back down. So this is a real-time display right here. There's a lot of pros and cons to the Labquest. One of the cons is the battery life is not really good. You have to charge them constantly, and some of the batteries even die, and you may have to replace. But the pros greatly outweigh that. There are so many different probes you can use alone or at the same time with each other. This thing can collect a lot of data from different probes at the same time. Before we perform the experiment, I'm going to show you, we are going to change. Right now the length of time is set for 180 seconds. I'm going to click on that, and I'm going to shorten that to 135 seconds. So all you have to do is come over here and highlight the amount of time, and I'm going to change that to 135 seconds. So I'm going to click OK, and now it's ready. The rate and the mode is time-based. That means it is going to take 2 samples per second, 2 samples of data. In this case, it's going to take the temperature twice per second for 135 seconds. You can change that mode to what's called events with entry, which is where you have to tell it when to collect data. But right now I want a pretty good graph, so I'm going to leave it on time-based. So I'm going to move this real quick and show you what I'm going to do. I have simply just some water in an Erlenmeyer flask, and I have some just an antacid tablet. So if you know your chemistry, when you drop an antacid tablet into water, a chemical reaction happens and the water will actually get colder. So that's an endothermic reaction. The energy that's possessed by the water goes into the breaking and forming of bonds in the chemical reaction. So when we take the temperature with the temperature probe, that's going to take the temperature of the water, and we should see that temperature go down. Now that's the good thing, is using the graph, we can show students the temperature going down. So To start collecting data, you can either click on this arrow in the bottom left-hand corner, that'll make your data collect, or you can press this arrow in the middle with your finger. Whenever you do this, you have to let students have the lab written out, and they need to read ahead in steps. There's a couple things that you have to do and know what's going on before you do this. So if you notice the temperature is at 28 degrees, I'm going to go ahead and I'm going to stick the temperature probe in the water. So now the probe is in the water, and if you notice, the temperature is now changing to 27.5 degrees, 4 degrees, because we want to get the temperature of the water to begin with, not the air around us. You put that in there and you let the temperature steady out. So right now we have a baseline temperature that's pretty steady. It's only varying 1/10 of a degree. So I am going to start collecting data. I'm going to wait 15 seconds, and then I'm going to place the chemical into the water. We're letting the temperature have a baseline here before we ever start anything. So once I start and press the play button, you're going to see a graph pop up, and that's going to be it collecting data. After 15 seconds, I will start adding the antacid tablet. So I'm going to go ahead and click it with the stylus. So you see it's switched to the graph. It's kind of tough to see, but the little red dot on the left, pick this up. That's your graph forming. In the bottom right hand corner is where the time is, and now that it's been 15 seconds, I'll start to add the antacid tablet. See how the battery is already going bad. Now, let me pick this up. It's kind of tough for you to see, but you can start to see that the little red dot is going down, down, down. On the left is the temperature, and on the bottom is the time. So what this is showing is that over time the temperature is going down. We're taking the temperature of the surroundings. So the surroundings are losing energy. And where is that energy going? It's going into the breaking and forming of chemical bonds in the chemical reaction. And so this is taking in energy for the reaction to go forward. That's an endothermic reaction. Endothermic reactions feel colder. So as you can see, that graph is going down. Now this doesn't look like a lot of change, but when you give this some time, we're going to let the reaction go all the way. We're going to see how the time is at 87, 88, 89 seconds. We're going to let it go the full amount of time, and the graph will readjust. Once that happens, there's a couple things that I can show you, a couple other usages for this. So the reaction has stopped. There's no more fizzing, there's no more bubbling, so it's not going to get any colder. In fact, if we let it sit here at room temperature, it's going to eventually warm back up, but our graph is going to stop after the amount of time that we've set. So in the bottom right hand corner, we're at about 125 seconds, so we have 10 seconds left to go. Notice how the temperature is leveled out. Okay, sorry, I lost power. If you notice down here at the bottom, it looks as though a battery with a power cord is inside of it. I had to hook the power cord over here onto the side. It showed in green a while ago. Let me pull this power cord out, and you'll notice down here at the bottom it is now yellow with a little bit of battery. Like I said, it's a con. It's a bad thing that the battery may be at halfway and may be green, and you may think you're fine, and then all of a sudden it jumps to hardly any battery whatsoever and it goes into the red. So the graph has readjusted itself, and as you can tell now, now it looks like a large decrease in temperature, but in actuality the bottom temperature is at 20 and the top is at 28, so we saw about a 8-degree change in degrees Celsius through the reaction. Now when you look at this, like I said, it's a touch screen. I can touch on any data point, like for instance right there or right there, and it will tell you the time and the temperature at that specific time. Now, if you want to make that easier to read, up here at the top you can click on the graph, and this will tell you the exact temperatures at any time you may want to see. So you can scroll down, and this goes all the way to 135 seconds, which was the end of our time. And if you notice, there shouldn't be much of a change in temperature throughout the first, I believe we let it go 10 or 15 seconds. So it's going to change, you know, a tenth of a degree, something like that, but really you should start seeing the change in temperature a little bit further down. So you can do the same thing with a hydrochloric acid, and zinc is really simple, and the liquid will actually get hotter, and you'll see the graph go up instead of down, and you can start talking about rates of reaction, solubility, and things such as that. The screen we're looking at right now is the table screen. You can click up at the very top, and there's your graph screen, and then you can go back to what's called the meter screen. I unplugged the temperature probe, so the temperature is just going to stay steady at 21.6 degrees. Thank you for watching my video, and if you have any questions about it, you can email me at john.smiley@tylerisd.org. Thank you.